Hello friends, welcome to ML with AP. In last few videos, we have covered a lot of ground. We have started with basics of Python, and then we moved on to syntax and semantics. We also covered data structures. And in last two videos, we discussed about the control flow, if, else, elif statements. And we in the very last video, we discussed about functions and lambdas. So if you have not gone through my previous videos, please, I highly recommend it to going through that to have a better understanding of what is going to come today. Okay. With that being said, let's move on to today's topic. Today's topic is equally important, and it is exception handling in Python. How do we handle exceptions in Python is the topic for today. Okay. Okay, friends. So what exactly is exception handling? What is exception handling in Python? No matter, in simple terms, if I have to explain, no matter how good a programmer is, how good you as a programmer or I as a programmer is, we all will eventually make a coding mistake. Okay? We all make a coding mistake. Now, such mistakes can happen due to coding mistakes or exceptions can happen due to various reasons, right? Now, various reasons, an exception can happen or a mistake can happen. Now, what are the essential reasons or the primary reasons? The first one is very simple: syntax errors or syntax errors. Okay. Now, what are syntax errors? As the name signifies, it is an error where the code is not valid syntactically. Okay, so there is a grammar which I have already discussed in the previous videos. There is a grammar for each language. For Python also there is a grammar. So if you are calling a particular method, you have to use small braces. If you are writing a code block, you have to start with a colon, right? So those are the Python syntax. If we are not mentioning those syntax, and generally these are the easiest to fix. Okay, easiest to fix. Why they are easiest to fix? Because most of the IDE will prompt you to fix it. It will highlight you, or Python will give you very good insight how to fix it. Okay, so this is the easiest to fix. We'll go in just in a bit, we'll go with the examples also. The second is semantic error. Semantics error. These are logical errors. So there is nothing wrong with the code per se. There is nothing wrong syntactically in the code, and the Python interpreter will execute. If you run the code, the interpreter will execute the code beautifully. There will not be any error. Okay, but the results are not what you were expecting. Okay, and we'll see that example also. So these are sort of logical or programming errors which are called semantic errors. These are the hardest to fix, because now Python is thinking that, hey, your program is running as you have written, but you are not getting the output which you are expecting. Now it's all up to you to figure that out. That's why it is the hardest to fix. The third type of error is your runtime error. These errors are where the code is syntactically valid, okay, but during the run or during the execution of the program, it fails. Okay, so let me go ahead one more time. The first one is the basic error, which is syntax error. We probably forgot a syntax, and that's why the error came. The second error is the semantic error, which is the logical error. Syntax is perfectly fine, but it's still the output is not what we were expecting. This is the hardest to fix. The third category is your runtime error. Now, runtime error, why it can come? The runtime error can come because of various reasons. The one is, let's say, to give you an example, if your program expects a user input and it is expecting an integer, Okay, and you are and the user input given was a string. There is nothing wrong with the program which you have written, but the program will run into a runtime error. Similarly, if the program is trying to open a file from the disk, that file doesn't exist. The program itself is written clearly and beautifully, and it's syntactically perfect. But what will happen during the runtime? The program will not be able to, your code will not be able to fetch a file, and it will result in runtime error unless you handle it gracefully. So the entire exception handling is that error will happen. How we can handle each and every scenario or each and every exception in a graceful way is all exception handling is about. Okay. Now this runtime error is somewhere in the difficulty level. If I have to say, it is between syntax and semantic error. Okay. Now the topic for today is we are mostly going to discuss about runtime errors today. Okay. Okay, let's see. So let's go ahead and give you a couple of examples so that it becomes very clear that what is syntax error, semantic error, and runtime error. Okay. So without further ado, what happened? Okay. Okay. Let's go ahead and go to our Jupyter notebook. Okay. The first example we'll give is syntax error. So syntax error, as the name suggests, is anything to do with syntax of the program, and we'll take an example and we'll keep that as a running example so that it becomes easier for all of us to understand. Okay. Now everyone who has done the basic geometry knows that circumference of a triangle of a circle is 2 pi r. So radius is r, circumference is 2 pi r, and if I have to calculate radius, what I have to do is 2 divided by pi. Okay, so this will be my, and this is, I'm just taking an example. There is nothing probably it's much easier for me to take one single example and run it through, and that's why I'm taking this example. There is nothing of significance of geometry over here. Okay. Okay, now let's see. If I have to define a variable, initialize a variable, I have shortened the circumference as circum and define it as 10. Radius became my circum divided by 2, and I will supply the value of pi, which is 7. Okay, so my radius, let me correct the spelling of radius over here. So my radius is circumference by 2 into pi. So this is the formula which I was going, and I have just put, and I've supplied a value of circumference as 10. Okay, now at the end what I'm doing is print radius. Okay, print radius. Let me execute it. There is an error. Now let's see what is this error. This error is calling a syntax error. Okay, why it is coming? Python, as I was telling you, that Python is very generous and it will exactly tell you what syntax error and where it is happening. So it is saying on line 9 print, and it's showing the place where it is happening. What is happening? Missing parenthesis to call the print. Okay, so this was an example of, I deliberately missed the parenthesis over here. This was an example of syntax error. Okay, once I print this, my value has come. So my radius, given the circumference is 10, my radius is 1.59 something something. Okay, now this formula is not of importance. This is just a way to show that what is a syntax error. Okay, now let's go and see that what is semantic error. As friends, you would recall that semantic error was something which is logical error. Okay, so I just copied the code and I will modify it to show you the example of semantic errors. Okay, now I just modified it a bit. Okay, now let's see what I have done. I have removed the braces from here and I have modified this comment as semantic error. That's all. This code is exactly the same. Let me run this code. Now my value of radius is 15. There was no error. There was no syntax error. Syntactically it is perfect. But I should be getting a value of 1.59 as my radius. Instead, what I am getting? I'm getting a value of 15.714. So this is, friends, what I was saying, that in semantic error, it's a logical error. You will, the code will run perfectly, but you will not get the value what you are expecting. Now let's see what is the problem over here. The problem is with the logic, and the logic is over here. Radius is equal to circumference divided by 2 into pi. But in this particular case, Python, I removed the braces over here. Okay. Initially there was brace. So if you know basic arithmetic, then you will know that parenthesis, this particular thing will execute first, and then circumference will be divided by the value of this. But if I remove the braces over here, what Python is doing, the order of execution for this particular code will be from left to right. Python always executes, and the precedence of division and multiplication is the same, right? So what Python, instead, in absence of parenthesis, what it will do? It will do the circumference 10 divided by 5, which is 2. It will multiply 2 into 22, which is 44, and then it will do the division over here, right? So the order in which I wanted this particular arithmetic expression to be evaluated will not remain the same, and hence I am getting a different value. This is a logical error or a semantic error, which is the hardest to figure out. It is the job of the programmer to ensure that the semantic errors are, and that's why we have the test cases and all those things which perhaps the QA people do. Okay. So let's execute it one more time. I got the same result as this. Okay. Clear? Now this was an example of semantic error. Now friends, let's go and see that what is the runtime error. Runtime errors. Okay. What are runtime errors? Now runtime errors is something which only, as the name denote, only comes at the runtime. Syntactically it is perfect. There are no logical errors, but there is something else when that particular code is getting executed at a Python interpreter level, it is throwing an exception. Okay, we do not know beforehand what exception it could throw, but we have to handle that gracefully. Okay, so let's see the example, and let's see again with the same particular example which we are seeing over here. Okay, I will copy it and I'll put it over here. This will become my example of a runtime error. Let's say I did a spelling mistake over here. Okay. Now, when syntactically, is it correct? Yeah, there is no syntactic problem over here. What it will happen is I have put this value into the variable radius, but when I'm printing an undefined value, undefined variable, which is raidus, right? So let's see what Python says. Python throw me an exception, a runtime exception in this particular case, as a name error. What is a name error? And it is also telling me exactly that where this is happening and why it is happening. It is happening because name raidus is not defined. So in case of runtime error also, Python is actually telling me that, hey, I am raising a name error, you go ahead and better fix it. So it is also somewhat easier to fix, and the way to fix is that you go ahead and correct the spelling, and essentially you are only printing those variables which are earlier defined in the program. Okay, so I will do that. So this was an example of runtime error. There are various examples of runtime error which we'll see just in a minute. Okay. Now let's see if I have to do something like this. Okay. This also we discussed in our previous videos, that this is a string type object and this is an integer. Okay. If I do an add operation, what will happen? It will throw a type error. Okay, what is the type error? Again, it is telling you the unsupported operand is this plus sign, unsupported operand type plus between int and str. So int and integers, int and strings cannot be added. But as you have seen in my last video, Can we add this? Yeah, it's a valid operation. Can I add A and can I add B? It's a concatenation operation and it will go fine. But once I start adding an integer and a string, this operand will throw an exception and of the type error. Okay, so there are various built-in exceptions, okay, which Python has, these built-in exceptions, and we'll see in a while that what are those built-in exceptions which handle these kind of, and how we can handle. Okay, now let's see another example. 2 divided by 0. Now if you know, friends, from your basic mathematics, the division by 0 is usually not defined. It's a very huge infinite undefined kind of value. So Python will also throw an exception, 0 division error, that the division by 0 is happening over here. I do not know how to represent this very large infinite type of value. Okay, so that was another example. Another example will be like, let me define a list type object. Okay, and I will define objects like 1 2 3 4 5. Okay, 5 elements. And now let me access 10th value. So there is no 10th value over here, right? In my list, this is the 0th, 1st, 2nd, 3rd, 4th. The length of the string is 5. There are 5 elements. Now there was a typo over here. Okay. Now let me see what this is going to. This is going to give you an index error. Why? Because we are trying to access a particular element from a list which doesn't exist, right? So it will throw you an index error, list index out of range. So it very clearly says that hey, you are out of range. You can only access till 4 0 1 2 3 4. So my 0 1 2 3 4. So my fourth element with the 0 index is element 5. Okay, so it says very clearly. Okay, now Python is very kind in the way that it always shows you the very meaningful exceptions. Okay, that includes information about what exactly went wrong, along with the exact line where it is happening. It is also showing that what is happening. So having access to these type of errors or exceptions is very helpful when you are writing a code or debugging your programs. Okay, correct. Now let's see that what is this, how do we, till now we have seen about the Python built-in exceptions, right? So we know that there are runtime exceptions, there are various type of runtime exceptions, but we do not know how to handle it. So let's try and see that how to handle it. Okay, so handling of an exception is essentially done by a mechanism which is called try and except block. So let's go over here. Okay, runtime exception, how it is handled. Now we'll see how it is handled. So it is essentially handled by try, and then we'll write some piece of code over here. Okay, some code, and then we'll write an except block. Again, we'll write some piece of code, and there are further advanced levels of this also, where we can use else, again with indentation, some code, and finally. So this is the structure. This is the structure of how runtime error or runtime exceptions are handled. Okay. Now we'll see that with an example, but let's try to think intuitively and understand that what it's doing. So if you have to put something, this try will always get executed. This whatever you are writing over here in some code block 1, or let's say code 1, whatever you are writing in code 1 block over here will always get executed till the time it gets an exception. Once the exception is caught, the program will go to the except block, and then it will start executing code 2. Okay. Now let's see a scenario where you have written the code in such a way that you have handled everything inside the try block, and there is no exception. If there is no exception, then the code will execute try block and will go to else block, which is code 3. Okay. Now, what is finally? Finally is that irrespective whether there was an exception, there was not an exception, finally code block 4 will definitely get executed. Okay. Now there is a reason why it is structured in this way, and we'll just see it in a minute with examples. But at a very high level, intuitively try to understand the try block is the main part of our coding logic or the code. If there is an exception, whatever type of exception, that is runtime exception which we encounter, it will go to code 2. Okay. If there is no exception, the code 1 will get executed, and the execution logic will go to code 3. Once code 3 gets executed, finally code 4 gets executed. Even if there is an exception and after code 1, code 2 gets executed, code 1, if let's say this, for the scenario where there is an exception, in that particular case, code 1 will get executed till the point an exception happens. After that, the program logic will go to code 2. Code 2 will get executed. Code 3 will not get executed because there was an exception, an except block was called. But finally, that code 4, this block will always be called irrespective of whether there was an exception or there was not an exception. Okay? Now let's see this with an example. Okay? Okay. Let me just create few more cells over here and bring it forward. Okay, so we'll go ahead with our running example of this particular radius. Okay, let me give you a new example. Okay, so x is equal to 1, my y is equal to, let's say, y is equal to also 1. Okay, I will write my code block. Okay, my try block will have I'm just dividing x by y. Okay, so let me divide x by y. Okay, and I am printing my division. Okay, this is simple. And finally, what I am going to do is I'm writing an except block over here, and I'm saying that okay, if there is an error, I will say that print some error happened. Okay, clear? So there was 2 integer variables which I have defined. I'm dividing them and I'm printing them. In case there is any error inside this block, what I will do is my command will go to, or the execution logic will proceed to except block, and it will proceed with this. Okay, let's see what is this. Okay, so this is nothing great is happening over here. 1 divided by 1 is 1. My except block didn't get executed. Correct? Any confusion? No. This is very simple and the naive case of this. Okay, now let's see. I will do something more funny with this. Okay, as I was saying, I will put y as 0. Now this particular logic will go 1 divided by 0, which is a 0 division error. We have seen over here 0 division error. So this code should also throw me an exception of 0 division error class. Let's see what happens. Okay, some error happened. Okay, so now this get executed. Python interpreter immediately knows that this is division by 0, I should raise an exception. So my control logic will go to except block, print some error happened. Some error happened, got printed. Clear? Now let's see. Let's go and try to handle this. That if some situations like this comes, how you can handle. One way to handle this is you put some logic where you identify that, hey, my y should not be 0, and if it is 0, you tell the user that, hey, you supply any other value, right? So what we can do is something like, okay, like we can print a statement or something that division by 0 is not accepted. Okay, please supply non-zero value. Okay, and this message will be read by the, we can pass it to the end user and he can enter another value, right? The other way to handle that could be that, hey, okay, you are supplying a 0, but what I am going to do is I'm going to default it to a very, very large value. So in this particular case, division by 0 is essentially infinity, right? If you divide any number by 0, it becomes a very, very large number. So I put a very large number over here. Okay, and again I am printing div. So this is another way of handling that, right? So I said that, okay, fine, if you have supplied 0, I'm just going to tell you that the result is a very, very large number, closer to infinity. Okay, this is another way of handling. But there is another problem with this particular logic. Okay, let's see what this problem is. Let me remove this code from here, and let me remove this. Okay, and I will copy this over here. Okay, there is another problem. What if I supply something which is a string? My input came with a string, right? Okay, and I'm going to do it by a string. Now, the whole logic I have written is that I'm expecting a division by 0, right? But let's see what happens over here. My except block is again catching this, but what is the exception we don't know in this particular case, because this is clearly not 0. What is happening is I'm trying to divide 1 by a string. Okay, so this should be something of this sort, right? I'm doing a mathematical operation between an integer and a string type, but since I have written my logic in such a way that my try block executes, and anything which exception comes, it thinks that it's a division by 0, right? Which is not correct in this particular case, as you can see. Correct? Now let's see how we can better handle it. Okay. Now the way to handle this is there are a lot of built-in exceptions which are provided by Python itself. Okay. Those built-in exceptions we can make use of. Okay. Let's see a complete, let's see in this particular example, then we can see the complete list of those exceptions. So let's see that I will mention it over here. The built-in exception, which was where I was dividing by 0 division error. Let me copy this. Okay. I'll mention it in this way. Okay. The way to read this is, hey, if you are doing this and if you encounter an exception, 0 division error, then only you execute this except block, otherwise don't execute. Okay, so let's see. If I put a 0 over here and I run it, this went to 0. I have already have an except block with 0 division error, so this particular line will get executed. But instead, if there is a data type error, like I'm doing an operation with a different data type, let's see what happens. See, it is a type error. Now my built-in exception is of type error, and it is saying that the division operation is not between integer and a string. It is clearly saying, but why it is not handled by except? Because this except block is only handling 0 division error type error or exception. It is not going to handle type error. Now you can guess that where I'm going with this. Okay, so to handle that would be, let me put another except block over here, and over here I will say type error. So my type error is also handled, and I will pass a message which is more like y is an string or something, supply an integer. Okay, now let me execute this. So in this particular case, since y was a string, my except block which gets executed is this one. Okay, y is a string, supply an integer, right? So I'm able to catch different type of exceptions gracefully, and I can build my program logic in such a way that if a particular type of exception, what action should be taken? If another type of exception happens, what action should be taken, right? So this is the way in which exceptions are being handled, the runtime exceptions are being handled in Python. Okay, now let's see one more example over here. Let me just copy this, paste it over here, and I'm seeing that instead of y being, I will supply y as a list. Okay, I made y as a list, and I'm dividing y by 1. Okay, the element 2, 0, 1. Okay, so y by 1. Let's see that what it has to print. Okay, it is dividing in 1 by 2, which is 0.5. Perfectly, no problem. Let me see what happens when I do 10. Now 10 is out of index, right? It is not present over here. Let's see what. Now it will throw me an index error. Now you can guess that why it is throwing index error, because zero division error, type error, both are handled, but index error is not handled. So what I should do is, maybe I can put a index error over here, or index error, this y is out of range. This is one way of doing it. The other way, if I do not know that, okay, what type of error I am going to encounter, I remove this and my except block will do catch all. It will, any unhandled exceptions by the except block, this will come here. And I can put something like generic, something bad happened. Okay. And any sort of error where apart from zero division error and type error, which is getting handled by the program, any other sort of exception which gets encountered over here will be handled by this particular except block. Okay, so this is like a everything apart from zero division error and type error will get handled over here. Okay, clear? Now let's move on. Okay, now let's see another thing over here. Okay, now let me do something which is y10 over here. Okay, now think, friends, what will happen over here if I put y10 in an except. Now we know that y10 doesn't exist because it is out of range, but what will happen? Let me execute this. Try, there was no exception. Okay, there was an exception of y10, that's why it went into the except block, right? And it was a division by it was an index error, so it went over here into except block, not type error and zero division error. Now it printed something bad happened. After that, if you see from my last execution to this execution, there is another error which is coming, index error. Now this index error is coming because of this. So the friends, what I wanted to tell you over here is, if you have a runtime error in except block in like this, it will not get handled by the preceding try block. Okay, now let me repeat one more time. If you have an unhandled exception in except block, it will not get handled by your try block. Okay, so you have to be very, very careful of what you are doing inside the except block, because this will remain unhandled. Okay, now let's move on. The different built-in exception which are present in Python for runtime errors. Okay, so till now we have seen index errors, we have seen type error, we have also seen something like zero division error, and we know that what are they, but there are many more which are there. Now let's see a comprehensive list of those errors. So this is called built-in exceptions. Now what we have seen type error. Now this is when two different types of objects, right? So if we are doing an addition between int and a straw type, right, then the type error will come. Name error, we also saw that when a variable is accessed which is not defined. Variable accessed which is not defined. Okay, name error will come. We also saw index error, which was out of bound error, the out of range, out of bound or out of range error. We also saw zero division error, and this was your division by 0, right? Now Python also supplies you a lot of other built-in exceptions. Let's go and try to see few of them over here. Okay, so it also has like EOF error, end of file error. If you have reached, like how you are reaching the index error, if you are reaching the end of file, you will get that. You can also get a key error. Key error, let's say you are reading a dictionary, okay, then and the key is supplied and the key is not found, then the Python will raise a key error. Okay, now let's see other ones like your there are tab errors. Okay, tab error. So if you have an indentation related error, that is called tab error. Apart from that, you'll also get something called value error. There are many more and a comprehensive list which is present on the python.org. Probably I will try to do a link over here in my description. But the value error is something like raised when a function gets an argument of correct type but of improper value. Okay, then the Python will raise value error. So in nutshell, there are various built-in exceptions which are present, which we have to make use of to gracefully handle exceptions, right? So we have to make use of the built-in exceptions to gracefully handle exceptions, right? Okay. Now let's see something which is we were discussing over here just a few minutes. Try, except, else, and finally. So we have seen till now try and except. Let's see what is this else and finally also does. We know how this gets executed. We have already discussed that. But let's see that how it actually, the else and finally also works in practice. Okay. So let me take our running example over here. Maybe I will take this. Okay. And let me just clear it out a bit, okay, so that we can get this example. Okay, and we did the except, and now let's do the else. Okay, okay, so I have added an else block over here, and I have written a print statement inside, only print statement that try completed without an error. Now friends, as I have discussed, that the order of execution is the first try gets executed. If there is an exception, it will stop at that moment, and what it will do is it will go and execute the corresponding except block. Corresponding except block means if it encounters a zero division error, it will go over here. If it encounters a type error, it will go over here. If it has encountering something which is not division error or type error or something which you have already listed out, it will go in catch all and it will go over here, and something bad happen will get printed, right? Now what is else block? If there is no error, then try block will get executed, except will not get executed because there was no exception, and else will get executed. Okay, now let's see. In this particular case, I am putting y subscript 1, so y1 is 2. Okay, so let's see what it is going to do. It will print 0.5 over here, so that my try block got completed. Also my else block got completed. Try completed without an error, right? So now you see the execution flow of how try. Now let's try to put finally also over here. Okay, and then we'll see that how to make use of it. And I will do a print again to keep it very simple. That let's close the program, exiting. Okay, so finally is something that irrespective of whether there was an error or not error, finally will get executed. Okay, so let's see what it will say. So it executed the try block. There was no exception. It didn't go into any of the except block. It executed the else, and finally anyway has to get executed because this is the end, right? Irrespective of what error or something happened finally. Now what is the use of all these things? And first before that, before the use, let's see that how one more time that how it gets executed. Let me just tweak it, and I made y subscript 10, right? Let's see. So I'm trying to access some element which is not present clearly. Now let's see what will happen. Okay, what is happening now? I tried to did this. This would have raised a what type of exception? It would have raised your index error, right? It would have raised an index error because index is out of bound. But am I handling index error individually? No, I'm not handling. So it would go in except block. It will not even print this division because after this, the execution logic clearly moved over here. Something bad happened. That's why there is no print division, right? After this execution, since there was an exception, my else will not get executed, right? But my finally will get executed again. So that's why it is, let's close the program, exiting. Okay, I hope friends this is clear. Let's see it one more time. Okay, let me put something like over here I will add an element 0, and then I will put y comma 0. Now this should be a division by 0 which is handled over here, right? Now let's see what happens. Again, this statement dot executed. This will not get executed. It get passed to here because I am handling it. Division by 0. This is getting printed, and my finally statement, my else didn't get executed. Clear? Now let's see. If I mention 2 over here, what will happen? Again, my try, my print also got executed. No error was over there. Again, my else got executed because there was no error, and finally got executed because finally anyway gets executed irrespective of whether there was an error or not. Now what is the use case, like why we are doing this? The way we are doing this is to gracefully handle all the programs. Let's see finally. How finally can be of use? Let's say you are opening a file somewhere in the program logic, okay, and you encountered an exception. Now that file will remain open. So irrespective of whether you are encountering an exception, whether it is handled exception or unhandled exception, you are still going, and according to the best practices, you are closing that particular file. Okay, so this is like you are closing, you are wrapping up everything. Whatever happened, whether it threw an exception or didn't throw an exception, you are finally clearing everything out. Okay, that's why we are using finally. Why we use else? Because suppose if you have to have you put all the checks over here in your try statement. Okay, now the try statement went through fine. After that, you want to execute the rest of the programming logic which you are going to put in else. So all my checks done in try. After that, my core programming logic will go into else. Okay, let's say you are building a program where you're taking two inputs, x and y in this case, and those are user inputs. You already validate that if my x is so and so, and if x is throwing this, if nothing happened and the try block was executing successfully, then you also want to, let's say you are calculating the circumference or area of a triangle. You want to calculate that in a else state, in the else block over here. So friends, I think it is clear that why else and finally are being used. Okay friends, I think I will take a pause over here. In the next subsequent video, we'll continue from where we have left. What we are going to see over there in the next video will be raise, accept, and we'll also see another important concept, which is how we define our custom exceptions. Okay, how we define the custom exception. So these are the two key concepts which we'll see in the next videos. Okay friends, till then, I hope you like this video. If you have any question or comments, please go ahead and put it in the comment section. I will try to answer those. If you like these type of contents, please do share and subscribe with your friends and family, and I will see you very soon in the next video. Okay, bye. This is ML with AP signing off.